Okay, here we are with a very preliminary demo for the Medical Innovations NUvention course. This is the radiology group, and I know we don't have a physical, tangible demonstration for this portion of our project, but instead what I have is a piece of software called LabVIEW, and LabVIEW emulates circuits, so we don't have to spend money to buy and then spend time to build, only to find out we've done something wrong. First, we can prototype something here in LabVIEW, see how it would work, and then buy the right components. So what we've done here is we put together an audio file of a fistula, a normal sounding fistula, and a abnormal stenosis sounding fistula, and we're doing frequency domain analysis on it. So remember, this goes back to the idea of when a patient goes into the dialysis clinic, the nurse listens through a stethoscope for different sounds of blood flow, and sometimes the nurse isn't capable of detecting when something's gone wrong. But we think it's possible for a computer or a microprocessor to do frequency domain analysis and be correct more often than a nurse is. So what we have here is a quick mock-up of a frequency domain analysis of audio files. So just to let you listen to the difference, I've got the audio file, and I'll play for you a normal and then the whistling sound. Okay, so it's obvious from there that there may be some problems. So hopefully we see some differences in the frequency domain. So I'm going to go ahead and run this, and this is the block diagram display. And if we go ahead and click in on the front panel display, I'm going to click run, and this is where all of our results will be. And oh, it's also playing it. And just to make sure we've got this set up properly, I put in a sine wave for a test. So we can see the sine wave up here at 250 hertz, so that shows up over here. Looks like we're doing something right. Now let's move on to the two audio files that we have put in. I'll go ahead and zoom in on a cycle of this, just so we have it for reference. Okay, and then I think from a very preliminary reading of published papers, the region of interest is under about 500 hertz. So I'm going to change the frequency of this normal audio file down to 500 hertz, and I'll also change the frequency display range for the abnormal one down to 500 hertz. And something that we notice right away is in the normal there's a peak somewhere around 150 hertz. Okay, we see that same peak, maybe a little bit lower, 125 hertz. And definitely a peak in the abnormal at 450 hertz that doesn't exist in the normal one. So this is just something to prove rapidly that we can do a frequency domain analysis on captured audio files. What we need to do next is find either in published papers what frequencies may signal abnormality and kind of hone in on that region. Thank you.